Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further, and next we'll be seeing the chapter from class 12th mathematics. And what's the chapter? The chapter that we'll be seeing is determinants. And this is chapter number 4 of your NCERT class 12th, and we'll be taking a look at exercise 4.1 in today's session over here. Exercise 4.1 is basically related to simple expansion of determinant, simple properties of determinants, and we'll be seeing each and every question one by one. Let's begin with the first question over here. The question says, evaluate the determinants in exercises 1 and 2. We simply have to find the value of this determinant, and let's see how do we go about finding this value. Finding the value of this determinant does not seem very simple. It does not seem very difficult actually. And what do we have over here? This is a 2 by 2 determinant. So the value would be simply equal to, you cross multiply this, 2 times minus 1 minus 4 times minus 5. This is what you have. You multiply these two and then you multiply these two, subtract them. So you have a minus 2 and a plus 20. So this is equal to 18. This determinant, the value is equal to 18. That's your answer for this question over here. Let's move on to the next one after this. The next one says that evaluate the determinant in this, and this time we have cos theta minus sin theta and cos theta. What will we do in this case? Let's try to solve this one. So the approach is similar and simple. We multiply these two and then we subtract this difference over here. The value would be equal to cos theta times cos theta minus sin theta times minus sin theta. Can you observe that there is a minus sin theta over here? So this is AD minus BC. That's the value of this determinant. This becomes cos square theta and this becomes plus sin square theta. The value of cos square theta plus sin square theta, as we all know, is 1. The value of cos square theta plus sin square theta is 1, and yes, that is my answer for this question. Simple, yes. Let's move on to the next one. This is the next one, and what does this question say? We have to find the value of this determinant. Let's see how do we approach this one. We'll have to multiply this and then subtract this difference. This is AD minus BC. So what do we have? This is x square minus x plus 1 times x plus 1 minus x minus 1 times x plus 1. This is what you'll have, right? Okay, and we'll have to simplify this further. Yes, for that let's multiply them together, multiply the brackets and see where does that take us. This is x power 3, okay, plus x square, okay, minus x square, minus x times 1 is minus x, then you have plus x plus 1 in this bracket over here, minus, what do we have? We have x plus 1, x minus 1, which is actually equal to x square minus 1 simply, okay. This and this will get cancelled. Okay, this and this will also get cancelled, and you have x power 3 plus 1, you have minus x square, and you have another plus 1 over here. This is what we have, and on simplification this becomes x cube minus x square plus 2. Yes, that is my answer for this question over here. Is that all? Yes, that's all in this question. Let's move on to the next one. If A equals 1, 2, 4, 2, then show that 2A determinant of 2 times matrix A is equal to 4 times determinant of matrix A. Let's see how do we get that. How do we solve this? This is a matrix A. So given A equals 1, 2, 4, 2, what is the matrix 2A equal to? The matrix 2A can be obtained by multiplying each element of this by 2. So each element of this when multiplied by 2 becomes 2, 4, 8, 4. Is that okay? Yes, this is 2A. Now we are supposed to find two things. We are supposed to find determinant of this 2A, and we are supposed to find determinant of A multiplied with 4. We are supposed to find those two things. So therefore determinant of A is equal to what? Determinant of A will be simply cross multiplying this. This is 1 times 2, which is 2, minus 4 times 2, which is 8. This is equal to minus 6. What about determinant of 2A? Can we find determinant of 2A? Yes. This can easily be found. This is equal to 4 times 2, 2 AD minus BC. This is what you have. AD minus BC. This is what you have. This is 4 times 2 is 8, minus 8 times 4 is 32, which is equal to minus 24. Yes, this is what you have. And can you please observe that this is equal to 4 times minus 6. Yes or no? Determinant of 2A is equal to 4 times minus 6. 4 is okay. This minus 6 is nothing but determinant of A. Yes. So from here you can say that determinant of 2A is 4 times determinant of A, as you can clearly observe by these calculations over here. So we were supposed to show that this is equal to this, hence proved. That's the complete solution of this question. By the way, this particular result is based on a property of determinants. What is the property of determinants? For a scalar lambda, and a square matrix A, the property says that, for a scalar lambda and this square matrix A of order equals n, we have lambda times A is another matrix, right? And if we want the determinant of this will be equal to, in terms of determinant of A, this will be lambda power n times determinant of A. This is what you'll have, right? For any scalar lambda and a matrix A of order n, the determinant of lambda A will be equal to lambda power n times determinant of A. This is the property. And can we memorize this property? Yes, you should memorize this for further applications, right? This is something which is very useful. Right? A lot of time questions are asked based on this simple idea. Right. So is that all in this question? Yes, that's all in this question. Let's move on to the next one after this. The next question says, if A equals this determinant, this matrix, there should be this matrix, right? Then show that 3 times A, determinant of 3 times A is equal to 27 times determinant of A. Once again, there should be a matrix over here. Okay. This should be matrix and matrix, right? If A is equal to this matrix, then show that this is the case. Okay, so for that, I'll require 2 things. I'm already given A. Can I find 3A with the help of this? Yes, since A equals this 1, 0, 1, 0, 1, 2, 0, 0, 4, this implies 3A will be equal to what? Now you can obtain 3A by multiplying each element of A, matrix A, by 3. So each element of A, this is 3, 0, 3, 0, 3, 6, 0, 0, 12. This is what we have, right? This is 3 times A. This is 3 times A matrix, right? What next? Let's further solve this. Let's further find the value of determinant of A and determinant of 3A. We can, on the basis of that, it will be very easy to simplify. Therefore, determinant of A equals what? So finding determinant of A is very simple. If you expand along this column, there are 2 zeros in this, or you expand along this row, there are 2 zeros in this as well. Let's expand along the first column. So what you have is 1 times 1204, okay, and let me write that determinant properly. That 2 by 2 determinant that will get 1 times this 1, 2, 0, 4 is the determinant that I am getting. Minus 0 plus 0 will be the other 2 terms. This is expanding along the first column. Along first column. Okay. If you expand along first column, this is what you get, and the value of determinant A will be equal to 1 times 4 minus 0, which is simply equal to 4. This is what we have. Determinant of A is equal to 4. Can we also find determinant of 3A? Yes, we can also find determinant of 3A easily. Let's focus on this. Determinant of 3A will be equal to what? Determinant of 3A can be found from here. Once again, expansion along the first column will give us, this is 3 times determinant of something, which is 3, 6, 0, 12. This is what we have. Right? Is that okay? Yes, that's pretty simple. And minus 0 plus 0. This is again expansion along first column. First column. That's what we have done. Right? Expansion along first column will give us this. This is 3, which is okay. Therefore, this becomes 36 minus 0. What does that become? This becomes 108. Okay. And what do we know about 108? Can you please help me with that? Yes. 108 is simply equal to, can it be written as, this is equal to 27 times 4, is it not? Yes. This is equal to 27. This is determinant of 3a. Yes, it has to be proved that it is 27 times something, and 27 times 4 is okay. What is 4? 4 is equal to determinant of a. So yes, this becomes determinant of a. Therefore, determinant of 3a is equal to this, and that's what we started with wanting to prove. Yes, have we proved this complete? Yes, we have proved this complete. This is determinant of 3a equals 27 times determinant of a. That's a complete proof of this question. Is that all? Yes, that's all in this question. Let's solve this question next. Evaluate the determinants. We are supposed to solve and find the value of this determinant over here. Now, how do we go about finding this value? It's pretty simple. As you may observe that there are 2 zeros in this row over here. Okay, so we can expand along this row and get the value of this determinant. Okay, so let's expand along second row. Okay, and what does this give us? Therefore, let's call this value delta, and delta will be equal to what? Delta will be equal to minus, there will be a minus over here, minus 0 plus 0, and there's a minus 1 over here, and the determinant that you'll have along with this will be a 2 by 2 determinant, which will be obtained by eliminating this row and this column. The row and column containing this minus 1. What will that be? 3 minus 1, 3 minus 5. This is what you have, right? That's the expansion of this determinant, and on the basis of this, the value will be, as you can easily observe, this is 0, 0 is gone, this is plus 1, and what you have over here is 3 times minus 5, okay, minus 1 times 3, that is AD minus BC, that's what you have, right? Okay, and this is 1, which is okay, this is minus 15, and this is plus 3. So this becomes minus 12, and yes, that is my answer for this question over here. This is the first part of 5th question from this exercise. Let's move on to the next question after that. We are supposed to evaluate the value of this determinant next. And how do we go about solving this? As you may observe, there aren't any zeros to begin with, and so we can expand along any row or any column. Let's expand along the first row. Expand along first row. So what will that give us? Therefore, delta will be equal to what? So in the first row, you have 3 minus 4 and 5. You'll have plus times 3, and the determinant that you'll have along with for 3 is 1, 1, 3 minus 2, 1, 1 minus 2 and 3. Then you have minus of minus 4. The term over there is minus 4. It will have an extra minus because of this expansion, and then you have 1, 2. The 2 by 2 determinant remaining after eliminating this row and this column will be 1, 2, minus 2, 1, as you may observe, and the third term will be plus 5. The determinant that you'll get is 1, 1, 2, 3. 1, 1, 2, 3. This is what you'll get, right? Okay, so this becomes 3, and this is 1 times 1 minus 2 times 3. Okay, this becomes plus 4, and the value of this determinant will be equal to what? 1 times 1 minus 2 times 2. Okay, plus 5 is okay. Then you have 1 times 3 minus 1 times 2. This is what you have, right? What else? What else? This becomes 3 is okay. 1 plus 6 is what you get over here. The next term will be 4 is okay, and in the bracket what I have is 1 plus 4 is what I have observed over here. The next term after that will be 5, and 5 times what? This is 3 and minus 2. That's the product. Okay, so what does this give me? This is 6 plus 1, 7 times 3 is 21. 5 times 4 is 20, and then you have plus 5. What this equal to? This is equal to 46 in total, and yes, that is my answer for this question over here. Is that all? Yes, that's all in this question. Let's move on to the next one after that. Let's solve this question. Now, what are we supposed to do in this one? We are supposed to find the value of this, and the value of this can be obtained easily if you observe that there are some zeros, but there are in different, all of these zeros are in different rows and different columns, right? So we can expand along any row for that matter. Let's begin the first, let's expand using first row. So therefore delta is equal to, first term is 0, okay? Next term is minus 1 times this determinant, minus 1, minus 2 and minus 3, 0. Minus 1, minus 2, minus 3, 0. This is what you have. What else? Then you have a plus 2 times determinant of minus 1, 0, minus 2, 3. This is what you have, right? Is that okay? Yes. This is 0, which is okay. minus 1 times what you have is minus 1 times 0 is 0, minus of minus 3 times minus 2 is what I get over here, right? Next term will be plus 2, which is okay, minus 1 times 3 and minus 0 times minus 2 is 0. Let's write it 0 only. What next? This is minus 1, this is minus, that becomes a plus, and this will be 6. So this is plus 6 over here. What about this? This is minus 3 and 2, which becomes minus 6, which will be simply 0. Yes, that's the value of this determinant. Okay. Can you observe one more thing over here? One more thing, one more important thing that can be observed over here is this, that the determinant over here, can you please observe the matrix which is hidden over here? Please observe this matrix. This matrix has all diagonal elements as 0 and the non-diagonal elements are just negative of each other. Yes. So do you recall that this is something called a skew symmetric matrix? Yes, this is something called a skew symmetric matrix. Now for a skew symmetric matrix, when we are taking a determinant, the value of some particular skew symmetric matrix are always 0. What's the special thing about such matrices? And please observe, for skew symmetric matrix of odd order, mind you, of odd order would imply of order 3, 5, 7 and so on. So for skew symmetric matrix of odd order, value of determinant is equal to 0. Value of determinant will be equal to 0. Odd order would be order 3, right? For a skew symmetric matrix of odd order, the value of determinant is simply 0, as you can see for this particular case over here as well. And this is one important statement which you can remember. For skew symmetric matrix of odd order, the value of determinant will be 0, right? That's something which you can observe. Let's move on to the next one after this. Evaluate this value. Okay, now how do we go about finding this value? What we can do is we can expand along any row or any column, and as you can see, there's a 0 over here, there's a 0 over here. We can expand along the first column. Yes, let's expand along the first column. First column would imply 2 times, this is 2 minus 1 minus 5, 0, minus 0 times something, and then you have a plus 3 times some other determinant, that's minus 1 minus 2, 2 and minus 1, right? For this 3, this will be minus 1, 2 and this over here. That will be the 2 by 2 determinant that we require, right? Next, this is 2, which is okay. 2 times 0 is 0. Minus 1 times minus 5 is what I get over here. Okay, what next? There's a plus 3 and I have minus 1 times minus 1 in the bracket minus 2 times 2. That's AD minus BC, right? That's a 2 by 2 determinant for us. And what else? This is 5, minus 5 times 2 is minus 10, okay. And plus 3 is okay. What is this? This is 1. And what's this? This is plus 4. Okay, this is what I get. The final value can be obtained very easily by simplifying this. This is 5 times 3, which is 15. 15 minus 10 is 5. That is my answer for this question over here. Is that all? Yes, that's all in this question. Let's move on to the next one after this. Sixth, if A equals 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9, find determinant of A. That's what we are supposed to find. Let's find the value of this determinant with the ideas and concepts developed. So determinant of A for this matrix, mind you, this is a matrix over here. This is not a determinant, this is a matrix, right? If A is this matrix, then determinant of A will be equal to what? This will be equal to, you can expand along the first row. Let's expand along the first row. So we have 1 and then you have this determinant which is 1, 4, minus 3, minus 9. Then you have a minus 1 over here. What else do you have? This is 2, 5, minus 3, minus 9. Then you have a minus 2, okay. The sign of this minus 2 for expansion will be plus, and then you have the value is minus 2 actually. So therefore this, and you have 2, 1, 5, 4. That's a 2 by 2 determinant associated with this, okay. Okay, and what else? This is 1 is okay. This is minus 9 and minus of minus 12 is what I get over here. Is that okay? Yes. AD minus BC, okay. Minus 1 is okay. This is minus 18 and you have a minus again, and then you have BC, which is minus 15 over here. Okay, minus 2 is okay. This is 4 times 2 is 8, minus 5 is what I'm getting over here. Next, 1 is okay. Let's forget about this. This is plus 12 minus 9. 12 minus 9 is 3 multiplied by 1. What is this? This is 15 minus 18, which is minus 3 times minus 1 is plus 3. And this is 3 times minus 2 is minus 6, and the overall value is 0. As you can clearly observe, the overall value is 0. Okay, and this is the value of this determinant. Is that all? Yes. Moving on to the next one after this. Find the value of x, values of x, if this determinant is equal to this determinant. Okay, so is this similar to matrices? No, this is a slight difference. Determinants have some value, right? So for solving this equation, what we'll do is we'll solve this value. This is 2 times 1 minus 4 times 5. This is the determinant. And what about this? This is 2x times x is minus 4 times 6. Okay, this becomes 2 minus 20 is equal to 2x square minus 24. And what does that give us? This is equal to, okay, 24 will come over here. 24 minus 20 is 4 plus 2 is 6. Okay, 6 will be equal to 2x square, and therefore x square will be equal to 3, which will give me x equals plus square root of 3 or minus square root of 3. That's the answer for this question. That's the answer for this question. X equal to plus root 3 or minus root 3, as you can observe over here. Next, let's solve this question. The 7th part 2. 2, 3, 4, 5, and then you have x, 2x, 3, 5, and we are supposed to find the value of x. Okay, so let's solve this. This is 2 times 5 minus 3 times 4 is the value of this determinant, is equal to x times 5 minus 3 times 2x. That's what we have, right? This is equal to 10 minus 12, which is equal to 5x minus 6x, and minus 2 is equal to minus x. And this will give me obviously x equal to 2. That is the answer for this question, as you can observe. Is that all? That's all in this question. Let's move on to the next one. This 8th question. The question says if x to 18x is equal to 6 to 18.6, then x is equal to what? Then x is equal to what? Then x is equal to what? Let's take a look at this one. So this equation can be solved by writing this as x times x minus 2 times 18 is equal to 6 times 6 minus 2 times 18. This is what we'll do, because these are not matrices, these are determinants, right? First find this value and then find this value. Oh, we were supposed to compare directly. Weren't we supposed to compare directly? No, we are not supposed to compare directly. These are not matrices, these are determinants, right? First find this value and then find the other value. This is x square minus 36, which is equal to 6 times 6 is 36 minus 36, and this will give me x square equals 36, which will further give me the value of x as 6 or minus 6. Those are the values of x. And which of them is the answer? Yes, option B is the correct answer for this question over here, as you can clearly see behind me. That's all for this question over here. And with this we come to the conclusion of this exercise based on determinants chapter number 4 of class 12th NCERT, right? This is the first exercise, and yes, if you have liked watching this video with us, please like and share this video with your friends, and obviously subscribe to the channel of Vyas Edification if you haven't done so. Till the next video, all the best.